So in yesterday's lecture, we have started this subtopic of alkenes. Okay, so first we have learned on how to name alkenes compound. Okay, and then next we will proceed with the reaction involving alkenes. Okay, all right. Bismillahirrahmanirrahim. A preview of preparation of alkenes. Okay, so to prepare alkenes, there are a few ways, okay, that we could use. One is by elimination reaction of alkyl halide. Okay, so we have these haloalkanes or alkyl halides where we have halogen in the molecule, in the compound. So we use KOH, potassium hydroxide, the alkaline solution in ethanol. So these are the conditions that you have to memorize. Okay, all right. So in order to remove, so basically we want to remove this halogen and another hydrogen from the adjacent atom. Adjacent mean next to the carbon that is bearing the halogen. In this case, it is halogen lah. Okay, so this one is next to each other. So normally it will involve these two carbon. Okay, so when this X is removed, this halogen is removed, same goes to the hydrogen from the adjacent carbon, and this double bond will be formed. Okay, so that is why one of the way to produce alkene is by using KOH in ethanol. So you have to specify. Okay, you have to specify the reagent. So these are what we call reagent and conditions. Okay, so if you somehow only mention the KOH without this ethanol, either the mark will be deducted ataupun you will be given no marks at all. Okay, so this is the struggling part lah, nak memorization tu nak kena ingat banyak sangat reagent that will be used in reaction. So different reaction may have different reagent because you want to produce different product kan. So by right they might have different reagent and different condition. Okay, like you want to cook asam pedas dengan masak lemak cili api ataupun kari. Okay, you mana boleh pakai daun kari dekat dalam asam pedas. Tak boleh kan? You have to have specific ingredient for asam pedas and specific ingredients for curry. Okay, so you kena memorize. Okay, so this is your, okay, in earlier slides for alkenes last time, we have UV light kan? UV light. And this one, that is the condition. Okay, so these are the regions that we need in order to produce alkenes. Okay, from alkyl halide. Okay, alternatively, we could also produce alkene from alcohol. Okay, we could use alcohol to produce alkene. So what are the reagents used here? The conditions that we need in order for this reaction to produce alkenes. Okay, so you require concentrated H2SO4 and also heat. So this is the condition that you have to be aware of. Okay, so what will happen is that this OH, okay, and also this hydrogen from the adjacent atom from the next carbon, will be removed out. It will be removed from the molecule, and therefore the double bond will be formed. Okay, all right. So that is how you can prepare alkenes. Okay. So this, on the other hand, is the reaction that alkenes can undergo. Okay, so the type of reaction that alkenes can undergo is known as electrophilic addition reaction. See the word addition here. In alkenes last time, we used the word substitution, the free radical substitution. Okay, the reason we use substitution because we want to replace one of the hydrogen with a halogen, for example. Okay, because all the bonds are fully occupied. We don't have any extra bond that need to be that will be formed for carbon, because carbon can only bears 4 bonds. So that's why the name of the reaction is known as substitution. Okay, sebab dia dah saturated, dah penuh. But for alkenes, it is known as addition because dia ada double bond. So this double bond, the pi bond, so we have sigma and pi kan, sigma and pi. So the pi bond is weak and it can be broken down and form another bond. So bila dia be broken down tu, nanti dia akan form satu bond on each carbon. Okay, right. So addition reaction is a reaction where an unsaturated molecule, so this is considered as unsaturated molecule because becomes saturated by the addition of a molecule across a double bond. Okay, so when we try to add it, for example, we want to add in this XY into this molecule. Okay, so the pi bond will be broken down. So the X and Y can be added across the carbon-carbon double bond just now. Okay, so we will say alkenes are relatively more reactive than alkenes. The electron-rich double bond is the active site or the functional group of the molecule. Okay, all right. So this is in general the name that alkenes can undergo. So it is known as electrophilic addition. Okay, electrophilic addition. Okay, so for alkenes alone, we have like five, what do you call that? 5 reactions. Okay, so we're going to start with catalytic hydrogenation. Let me just name all of it, okay? And then we are going to cross. Once we have covered each one of them, we are going to cross from the list. Okay, so reaction for alkenes. Okay, all right, so we have hydrogenation. Then next we have halogenation in inert solvent. And then next we have still halogenation, but in water. Okay, and then the fourth one we have hydrohalogenation. And then the fifth one we have hydration. Okay, so we are going to cover all of them. So as you know, every reaction will have its own reagent, its own conditions. So those kind of thing you have to memorize. Okay, sebab when you are asked in exam to specify the reaction, to name the reagent, you must be able to do that. Okay, right. So let's start with this one first, hydrogenation. So once we are done with this one, we are going to cross off this from our list. Okay, somehow ni dia psycho saya untuk menunjukkan yang okay, aku dah cover the first one, and then let's move on. Okay, untuk saya dia sangat-sangat membantu. So saya selalu akan ada my things to do list. Kalau saya get overwhelmed kan, banyak sangat kerja nak buat, I will list out everything and then I will go one by one and then I will cross off. Okay, and then saya akan tengok saya punya list tu bila berjaya cross off, somehow dia ada satisfaction di situ. Okay, itu cara saya lah, cara awak saya tak tahu. Okay, catalytic hydrogenation. Okay guys, so basically hydrogenation lah. And then why do we have catalytic there? Because this reaction requires catalyst. Without catalyst, the reaction will not take place. Okay, so basically we are going to add in hydrogen into alkenes. So the pi bond will be broken down and then hydrogen can be added on both carbon. Okay, so addition of hydrogen to a double bond to yield an alkene. So it will produce alkene here, okay, as the product in the presence of catalyst. So since this is a reaction of alkene, so we're going to start with alkene, react with hydrogen gas, okay, in the presence of catalyst. In this case, nickel is one of the catalysts that is commonly used, in hydrogenation reaction. So it will produce an ethane. So as you can see, both hydrogen will be added for both carbon. So what are other catalysts that can be used in this reaction? So other than nickel, we could also use platinum or palladium. If you are using platinum or palladium, so these are the temperature that you have to take note of. Okay, so temperature will be 25 to 90 degrees Celsius. If you are using nickel, then the temperature should be 140 and until 200 degrees Celsius, which is higher than the platinum and palladium. Okay, so make sure that you have nickel when you write the equation for hydrogenation. Make sure that you have nickel. Without the catalyst, basically catalyst lah. Without the catalyst, your reaction will be considered as wrong because that reaction will not produce product and will not happen in the first place. Okay. Okay, moving on. Let's try on this checkpoint. The reaction below undergo catalytic hydrogenation. Draw structural formula of the product formed from catalytic hydrogenation. So these are the alkenes. Okay, so these are the alkenes, and you can see that hydrogen is placed on top of the arrow. Okay, so it can be, the hydrogenation can be represented this way. Maksudnya you have tambah hydrogen gas, or you can also place it on the arrow. Okay, so on the arrow to for hydrogenation reaction. So what happens is that this pi bond will be broken down, so dia akan buka tangan ni dekat situ. Okay, bukan tangan lah, bond lah, the extra bond there, and the hydrogen will be added for these two carbon. That is all. So you produce alkenes from this hydrogenation reaction. Okay, same goes to this one. So this one will no longer be there. So we will have hydrogen there. So since you are using skeletal, so hydrogen will not be shown. Okay, so basically you will be drawing the same structure, it's just that without the double bond. As simple as that. Same goes to this one. So this one will be broken down. Actually, the hydrogen will be added there. Okay, since this is skeletal, hydrogen will not be shown. Therefore, you basically have the same exact structural formula, but without the double bond. Okay, without the inilah. So exactly the same without the double bond. Okay, very simple for hydrogenation reaction. Dan jauh sangat nanti dah tak larat nak patah balik. Cancel. Okay, so terus je hafal. Hydrogen H2 and then dia punya catalyst platinum or nickel or palladium. Okay, the reaction, the temperature, if you are using nickel, then it will be 140 until 200 degrees Celsius. Okay, all right, then next, move on. Let's move on to halogenation in inert solvent. If you have question, please feel free to interrupt. Okay, all right, halogenation in inert solvent. So for this reaction, what we want is to add halogen into the molecule. Okay, specifically on the carbon that has double bond. Okay, okay. So unlike alkene, alkene can react with halogen like chlorine or bromine at room temperature and dark condition. Okay, so in comparison to what we have learned for alkene last time, alkene, okay, cannot simply react with halogen in dark condition. and at room temperature. Okay, so alkenes require specific condition, which is to have the, what do we call that? The UV light. Okay, so it should not be in dark condition lah, but okay, conversely for alkenes, okay, the reaction can be performed, okay, in dark condition. Itu bezanya. Okay, alright. So basically we have alkene. Okay, so we have the halogen in inert solvent. Inert solvent, that means inert means the solvent will not take part in the reaction. Inert kan, it will not take part in the reaction. So only Br will be involved in the reaction. Okay, alright. So macam biasa, the pi bond will be broken, so the bromine will be added across the carbon double bond, carbon double bond just now. Okay, because the pi bond dah break just now. Okay, so F2, so please take note that fluorine is too reactive. So normally we don't go for fluorine. Okay, and iodine just does not add. Okay, iodine tak boleh simply add directly into the alkenes. So we would go for chlorine and bromine only. Okay, so what are the inert solvent that commonly used? CCl4 and CH2Cl2. Okay, so these two are considered as inert and it won't take part in the reaction. Okay, alright. Ini kita bagi contoh-contoh yang senang. Senang as in, kenapa? You nampak dia macam simetri kan? Sini, okay, you belah dua, you akan nampak. This one, this side is the same as this side. This is considered easy example. Nanti kita akan ada contoh yang a bit complicated. Okay, and after all, both are also Br. We have two Br atoms. So both will be added. Okay, either part pun tetap Br dua-dua yang akan masuk. Okay. Then, and for halogenation in inert solvent, guys. Ini senang. Yang ni yang kita akan ada this one. We have mechanism for this one. Okay, we have mechanism. That means we have the step-by-step process and also this one. The rest kita tak ada mechanism. Kita bukan tak ada. We are not focusing on the mechanism. Only the targeted reaction saja. Okay, moving on to number 3. Reaction number 3 is halogenation in water. As you can see, the solvent used is now different than the previous reaction. Okay, so alkene can react with aqueous halogens because we use water, right? So that's why we have the word aqueous there to produce halohydrin. Halo stand for halo. Halo stand for halogen. Hydrin stand for hydration. Okay, hydrate from hydroxyl. Okay, from water lah basically, from water. So halohydrin is an alcohol with a halogen on the adjacent carbon atom. Okay, alright. So consider this example. So we have alkene. So this is the halogen, and we have water as the solvent. So water will take part in this reaction. Okay, water will supply the OH group, and the halogen will supply the X or the halogen itself. Okay, so this is the product produced, and this is known as halohydrin. Okay, halo because of the presence of halogen, hydrin because of the presence of hydroxyl group. Okay, all right, so you have to be careful, you have to specify, you have to read the question carefully. Is it halogen in water or is it halogen in inert solvent? Because both will produce different product. Okay, all right, so kat sini dia dah ada sedikit preference. As you can see, we have X dengan OH. We have like halogen and OH dekat situ. Okay, kalau dia simetri senang. Simetri maksudnya dia boleh masuk mana-mana. X boleh duduk dekat sini ataupun di sini. Same goes to OH. OH can be placed here or here because both of them, this molecule is considered as symmetric. How about if the molecule is not symmetric? The unsymmetrical molecule. So dekat situ akan ada preference. Kan? Sebab dia case macam probability juga. OH akan masuk dekat sini, boleh masuk sini, OH boleh masuk sini. Halogen pun boleh masuk di sini, di carbon ini, dan halogen juga boleh masuk carbon di sini. Ada that probability kan? So that's one thing yang kita akan look into that. Okay, azan. So kita stop sekejap. We will continue after this. Okay. Okay, all right. So alhamdulillah, let's proceed. Halogenation in water just now. Okay, so in water, chlorine dissolved to form hydrochloric acid and chloric acid HOCl. As for bromine, also dissolved to form hydrobromic acid and bromic acid HOBr. Okay, all right. So these are the product of halogen dissolved in water. Okay, so we have HOBr and HOCl. Example. So so OH will be slightly negative than Br. Okay, OH will be slightly negative than Br. So Br will be slightly positive compared to OH. Same goes to for HOCl. Cl will be slightly positive than OH. Okay, all right. So this is what we call electrophilic part. Okay, the partially positive part is considered as electrophilic. So example, so we have ethene here, right? So bromine in water. So we know that bromine will be added as well as the hydroxyl group. Okay, all right. So this is what we call bromohydrin. That means we have OH and also Br. Okay, all right. So please take note. Okay, I'm sure that you are already by now you should know that alkene is also considered as nucleophile. Okay, because of the density of electron is higher for alkene. So nucleophile for the alkene will attack, okay, the electrophile in HOBr ataupun in HOCl. Will attack the halogen part. Okay, so in the first place, Br will be added. Okay, first and then followed by OH. Okay, so that's the idea of it lah. Okay, in terms of mechanism, but we are not going to cover the mechanism for this reaction. Okay, you just need to know that Br and OH will be added into the alkene. Okay, so this is the one that I've mentioned to you just now. Yang ini tadi saya kata dia symmetry. The molecule is symmetry. Macam mana tahu dia symmetry? When you try to cut this into two, you will get the same side. Okay, the same side for both carbon. Macam sama. So this is what we consider as symmetry. Okay, so but not all molecules are simple as this. Okay, so we have very complicated molecules, even like this one. This is not considered as symmetry. This is considered unsymmetrical alkene. Okay, unsymmetrical alkene. Okay, if unsymmetrical alkenes such as propene react with halogen in water, the electrophile, okay, which is Cl or Br just now, yang saya katakan yang positive side tu. The positive side will be electrophilic. Okay, that will be electrophilic. So the electrophile, Cl or Br, adds to the less substituted carbon. And nucleophile, which is the OH, okay, later on, adds to the more substituted carbon. What do you mean by less substituted and more substituted carbon? Okay, all right, so look at the example. So this is propene. Okay, kita punya target is on the double bond. The rest tu dia bagi complicated macam mana pun abaikan saja. Just carry forward. Okay, but the target is on the active side ataupun on the functional group, which is in this case the double bond. Okay, all right, so we have carbon number 1 and carbon number 2 that is that are having the double bond, right? So how do we consider which one is less substituted carbon and which one is the more substituted carbon? Okay, the first one is considered as less substituted carbon. Okay, less substituted carbon. Okay, maybe you can imagine this substituted carbon as as alkene. Okay, all right. So the the easier form, I mean bukan easier, the simplest form, okay, of alkene is this one. Okay, so initially we have all hydrogen. So when this hydrogen, okay, is being replaced, okay, this is what we call less substituted. Sebab dia punya asal dia tu memang hydrogen. Okay, when we replace this hydrogen with something else, that is what we call dah disubstitute. Okay, when we replace more hydrogen in for this carbon, itu yang kita kata more substituted. Maksudnya, for more substituted carbon, it has less hydrogen. Sebab hydrogen has been replaced with carbon, with alkyl group. Okay, so that is what we meant by more substituted. More substituted means less hydrogen attached to the carbon. Sebab dah diganti dengan carbon ataupun other alkyl group. Okay, alright. So that's why this carbon number 1 is considered as less substituted carbon because it has more hydrogen. Okay, so Br will be attached to this carbon. Br will prefer to be attached to the less substituted carbon. On the other hand, OH will be attached to this more substituted carbon. Okay, this carbon is considered as more substituted. Okay, this one is less substituted. So OH will be added at the more substituted carbon. So dia become macam ni lah. OH and then Br. They mesti involve between these two carbons saja. The rest will remain the same. Okay, so that is what we call preference dekat situ. Dia ada syarat dia. Sebab dia ada dua probability dekat situ. Br boleh either masuk dekat sini ataupun di sini. Okay, tapi which one does Br prefers more? Mana satu? Macam kita prefer yang ada aircon ke tak ada aircon? Dua-dua pun kita boleh duduk kan? Tapi kita prefer ada aircon ke tak ada aircon? Kita prefer ada aircon lah sebab lebih sejuk. Contohnya macam tu. Okay, same goes to this one. OH prefers to be placed at the more substituted carbon. Okay, alright. Sebab nampak tak kenapa this is considered as more substituted carbon? Because it has less hydrogen. Yang ini sepatutnya hydrogen has been replaced with this group. That's why this one is said to be more substituted carbon. Okay. Okay, check point 13. Write the structural formula of the product form when each of the following alkenes react with bromine in water. Okay, so for bromine in water, you have to remember that Br and OH will be added into alkenes. So identify the double bond. Okay, so these two carbon has double bond. Okay, and then identify the less substituted and more substituted carbon. Okay, all right. So this one is more substituted because it only this carbon does not has any hydrogen attached to it sebab dia dah ada 4 bond. 1, 2, 3, 4. Dia tak ada hydrogen at all. But this one we have 1 hydrogen. Okay, we have 1 hydrogen. It's not shown. Tapi faham-faham sendiri lah. This is skeletal. Okay, alright. That means this is less substituted. This is more substituted. Then OH will be added. Will prefers to be placed here. Br on the other hand will prefers to be added here. Okay, alright. So what you need to do is to draw everything the same as the original molecule just now. But without the double bond lah. And please add in the OH and Br. Okay. Alright. Same goes to this one. B. Okay. Identify. So this is the molecule. So this is the double bond. Okay. Identify the more substituted and less substituted. Okay. So this would be the less substituted. Sebabnya sebenarnya di sini ada 2 hydrogen sebenarnya that are not shown. This one, we don't have hydrogen here. We don't have hydrogen here because it's already 4. 4 bonds. 1, 2, 3, 4. Dah cukup dah 4. Okay, that means OH will be added here. Br will be added here. Same goes to this one. Okay, so this will be less substitute. This will be more substituted. This one will be less substituted. Okay, so nanti dia akan break. So dia akan form, dia akan place the OH here. Br will be placed there. Okay, right. So these are the answer. Without the double bond, okay, it's basically the same. Sama je dia punya structural formula, but without the double bond and the addition of OH and halogen. Okay, right. Okay, moving on. Okay, then for both halogenation. Okay. Mana saya punya ni tadi? Dah tak ada lah, dah hilang. Dia dah hilang lah. Okay, alright. So moving on to hydrohalogenation, guys. So before we proceed to hydrohalogenation, so this is the one that we have. We are going to have our first mechanism for alkene and also hydration later on. Okay, the 3 earlier reaction we don't have. We are not covering for the mechanism. Okay, so far, are you guys following? Are you guys following so far?
Yes, madam.
Yes, madam.
Yes, madam.
Okay, so far so good. Bagus. Terus dia ingat dia punya reaction dia apa, dia punya product dia punya reagent and whatnot. Okay, right. So let's move on to hydrohalogenation. Hydrohalogenation, hydro stand for hydrogen lah. Halogenation, halogen stand for a halogen. It's either Br or Cl. Okay, that means we have hydrogen and halogen involved in the reaction. So these two will be added into the molecule. Okay, so alkene react with hydrogen halides to form alkyl halide or haloalkenes. Okay, for example, so this is alkene. So this is the hydrohalogen. Okay, atau hydrogen halide. Hydrogen halide. Okay, so basically these both will be added into the molecule and it becomes, this is what we call haloalkenes because it is already saturated but with the presence of halogen. Okay, all right, so relative reactivity of Hx towards alkenes increase in the order of HF, HCl. Okay, HF is the least reactive. HI is the most reactive. Okay, so HCl and HBr are in the middle. But normally we will go for HCl and HBr. But for the previous halogenation, right? But this time around we do have HI. Kita ada HI. Okay, tapi yang tadi tak ada HI. Tak ada iodine. Okay. Alright, so reaction of unsymmetrical alkene with Hx follows Markovnikov rule. So the first rule that you have to remember, you have to memorize, is known as Markovnikov's rule. Okay, so we have a rules to decide on. Macam case study, okay, dia ada preference. Okay, so this Hx, when it is added into unsymmetrical molecule, dia ada 2 probability dekat situ. Dia boleh masuk this carbon and it can also be added to this the adjacent carbon. Okay, but it depends on the preference. So this preference is stated in Markovnikov rule. Kita kena follow this rule. Okay, so the first rule that you will learn in this topic 5 is known as Markovnikov's rule. So we have 2 rules so far. Satu this Markovnikov, the other one is CHM. Itu je. Okay, for your syllabus. Untuk yang advanced sebenarnya lagi banyak rules. Okay, right. So we going to start with Markovnikov rule. later we will go into detail what is Markovnikov rule. Okay, what is stated in Markovnikov rule. Jenuh mulut nak sebut. Okay, so this is the mechanism of electrophilic addition, the what we call the skeletal, okay, or the idea on how electrophilic addition takes place. Okay, alright. So basically kita ada alkene kan. Alkene will behave as nucleophile. Okay, so the nucleophile, dia orang yang kaya, dia banyak elektron kan, so it will attack the electrophile. Okay, so electrophile orang miskin, poor in electron, so dia hanya akan di-attack. So nucleophile will attack the electrophile. Nampak tak penggunaan arrow dia dekat situ? Dia pakai full-headed arrow. Lepas ni semuanya full-headed arrow. The half-headed arrow will only be used in alkenes. Okay, in alkene sahaja. Okay, the rest kita pakai full-headed arrow. Okay, dia akan attack the electrophile. So attack as in electrophile will be added into the molecule. That means the pi bond will be broken down. See, nampak? Dia akan break the pi bond. So electrophile will be added to one of the carbon. Dia masuk satu-satu dulu, step by step. Okay, dia masuk satu-satu. So dia masukkan dekat this carbon, for example. Okay, but how about the other carbon? So the other carbon tu dia kena hold down first. Dia kena sebab dia step by step kan. So it will become carbocation. Okay, sebab yang di add first dulu for this carbon only. This carbon will later on kita akan add with other species, which is the nucleophile. Okay, so this is what we call carbocation. This is the intermediate, guys. Okay, the intermediate of this reaction. So dia masukkan satu, so here will become the carbocation. Then later this carbocation, as you know, it is unstable. Because why? Carbon prefers to have 4 bonds. Now dia hanya ada 3 bonds. So it is unstable actually. Okay, alright, so that's why it will only become an intermediate. So it's just a transition state lah. Okay, transition state. It will happen temporarily, okay, until the nucleophile attack and add itself to the carbocation. Okay, alright. So dia jadi carbocation. Carbocation is an electrophile. Sebab poor in electron kan. So the nucleophile will attack the carbocation and add itself to the carbon. So kita akan ada E, the electrophile and nucleophile in this molecule. Okay, just for your information. So hydrohalogenation kan just now. This is HBr. For example, HBr, HCl. So this is the reagent used. Okay, so if we were to compare the electronegativity between this H dengan Br, so we know that H is slightly positive, right? Br is slightly negative. That means H is electrophilic. So first step adalah electrophile ni sebenarnya dia akan masukkan hydrogen sebenarnya. Hydrogen will be added first. Okay, so hydrogen ni akan putus, so hydrogen dia akan jadi H+, so hydrogen will be added first, so Br later on will become Br-. Br- is not slightly negative, dia memang negative. It is an ion. It is an ion. So it is nucleophile. It is nucleophilic. Therefore, later it will attack the carbocation just now and add itself to the carbon. Okay, ini skeletal mechanism lah on how the mechanism takes place for hydrohalogenation. Okay, dia basically 2 step. Mula-mula double bond attack the electrophile. Okay, and then they form carbocation. And then this carbocation, the nucleophile pula attack the carbocation. Okay, 2 steps. Okay, let's look at example. Hydrohalogenation of unsymmetrical alkenes governed by Markovnikov rule just now. Okay, so propene is considered as unsymmetrical, okay, because we have methyl group on this carbon number 2. Okay, on carbon number 2, so we have double bond here. So the targeted the active site will be the double bond. Okay, so the idea of it, kita akan tahu this one will be broken down. So dia akan buka tangan dia dekat situ, dia buka bond dekat situ, H dengan Br will be added. Okay, alright. So this one, bila dekat sini, apa yang berlaku adalah H will be added at this first carbon. Okay, H will be added to this first carbon. So that's why, as you can see, the blue hydrogen here shown that the hydrogen come from HBr. Br pula akan masuk pada carbon number 2 lah. Okay, so this is the sole product form, the only product form. So kita kan tadi macam saya cakap kan, ada probability kan, dia ada possibility Br boleh duduk dekat sini, Br can also be placed here, but not for this one. Not for this one. Because why? Cuba tengok kita plan, okay. So probability number 1, H will be added at carbon number 1, Br will be added at carbon number 2. Probability number 2, kita sangka, kita rasa that dia terbalik pula. Br duduk dekat carbon number 1. H okay, will be placed at carbon number 2. But in reality, this is not possible. This product will not be formed. It will not be formed. Okay, kenapa? Kita akan tengok later. Dia ada sebab kenapa this one tak boleh form. Tapi nanti bila ada case yang di mana ada dua probability tu, boleh pula form. Dia ada benda yang consideration yang you kena consider. The stability of the carbocation ion. Remember just now? Ini equation. Tapi sebenarnya nak menghasilkan produk, dia kena lalu the 2 step just now. So dia akan lalu this carbocation ion. Dia mesti form carbocation ion. Okay, they mesti form this carbocation. So kenapa this one will not be formed? Okay, but before that, you have to know the Markovnikov Rule state that when an unsymmetrical alkene reacts with hydrogen halide, like HCl, HBr, or HI just now, the hydrogen adds to the carbon that has greater number of hydrogen, and the halogen adds to the carbon of the alkene with fewer number of hydrogen substituent. This is the same that what we have learned for halogenation just now. Halogenation in water just now. Dan yang more substituted dengan less substituted. It is the same. It's more or less the same. It's just as Markovnikov ni more dia specific for hydrogen halide. Okay, I think it was introduced during this hydrohalogenation, but the concept is the same for halogenation in water just now. Okay, the OH, the more nucleophilic ataupun the more nucleophilic species, okay, will be added to the more substituted carbon. Okay. Okay, jom tengok contoh dia punya step sebenarnya, what actually happened for propene just now. Okay. Okay. So tu tadi Markovnikov yang cakap. Okay, Markovnikov kata the hydrogen will be added to the carbon that has more hydrogen. Br will be added to the carbon that has less hydrogen ataupun more substituted carbon. Okay, alright. So step dia, the nucleophile attack. So nucleophile will attack the hydrogen, which is electrophilic. Okay, electrophilic, dia akan attack the hydrogen, dia nak remove the hydrogen from HBr. So what actually happened is that this bond will be broken down. Okay, this bond will be broken down, so the shared electron will be given to Br. The shared electron, the 2 shared electron will be given to Br. So Br now has extra electrons, so that's why dia jadi Br minus there. Okay, H will be added first. Okay, H will be added first. And this will form secondary carbocation. This carbon is settled already. This adjacent carbon is now becoming carbocation. So this is secondary carbocation. How do we know that this is secondary carbocation? Because this carbon is attached to another 2 carbon. That's why it is secondary carbocation. Okay, because it is attached to 2 other carbon. So that's why it is secondary. Okay, and then later on, the Br minus just now, the nucleophile. So dia jadi nucleophile now, so it will attack the electrophile, in this case, the carbocation, and add itself to the carbon. So see, nampak? Simple saja. Okay, alright. So ini yang dia preferred just now. This one, the sole product. This one will not be formed kan? Okay, kenapa dia will not be formed? This one, yang kita sangka ni boleh juga ni macam ni. Okay, alright. So option ni kan sepatutnya this is what we plan lah. Okay, so H macam biasa nucleophile attack the hydrogen. Hydrogen will be added instead of here just now. They add to this carbon. Okay, option number 2. So hydrogen will be added to this more substituted carbon ataupun that has less hydrogen. So this carbon will become carbocation. So this is considered as primary carbocation because this carbon is only attached to 1 carbon only. This carbon is attached to 1 carbon only. Okay, so therefore it is called primary carbocation. Okay, the thing about primary carbocation, why it is very unpreferable, okay, because it is very unstable. Itulah masalahnya. That's why dia tak terform, dia tidak akan form. It is unstable and therefore it will not be formed. Okay, so kita expect, okay, dia jadi macam ni, jadi primary carbocation, and this nucleophile will attack the carbocation, right? And add itself to the carbon and become this one. But this is not happening. It will not happen this way. Tidak akan berlaku. Itu hanya expectation kita. Tapi in reality, it will not happen because of this stability of carbocation. So carbocation stability is something that we have to consider. Okay, that's the reason why. Okay, stability of carbocation, like I said just now, in electrophilic addition to an unsymmetrical alkene, especially for unsymmetrical alkene. Kalau symmetrical alkene is not a problem sebab dia boleh masuk. Either way pun dia tetap produce the same molecule. Okay, it's not a problem. So unsymmetrical molecule is can be complicated, a bit complicated because it involves the stability of carbocation. Tapi taklah complicated mana once you dah tahu the reason, senang je. Okay, so in electrophilic addition to an unsymmetrical alkene, give the more highly substituted carbocation intermediate. Okay, maksudnya carbocation prefers to be formed for more substituted carbon. Okay, that has less hydrogen. Okay, because kenapa? Highly substituted carbon, okay, highly substituted carbocation, that means the carbocation has less hydrogen and it has more carbon, okay, form faster. Okay, it can be formed faster than a less substituted carbon, the one that then a less substituted carbocation, like primary carbocation just now. Okay, and rapidly goes on to give the final product. So lebih senang nak form dan lebih senang nak form product. Okay, so and then the second reason is the highly substituted carbocation, okay, is more stable. It is more stable. Why is it more stable? Because of the inductive effect. Familiar with this term? Okay, so we have learned this term in topic 3 last time in Acid and bases, ingat tak inductive effect, withdrawal effect. For the acids, kenapa acid ni dia very weak? Because of the inductive effect. Okay, the hydrogen, in order to become stronger acid, the hydrogen need to be easily removed. Tapi because of this inductive effect, okay, dia membantu menolak the electron density towards the bond, so the bond become even stronger, so it will be harder ataupun difficult to break the bond, and hence removal of the hydrogen will also be harder. Okay, so itulah inductive. Tak ingat? Pergi buka balik topik 3 Okay, so order of increasing carbocation. So we would say that tertiary carbocation is the most stable form. Because why? Dia attach kepada 3 carbocation. 3 carbocation. 3 carbon. Okay, so this carbon will help to stabilize this carbocation. Dia tahu carbocation memang tak stable. Tapi dalam banyak-banyak yang tak stable, mesti ada yang lebih stable sikit. Okay, kita tahu ni semua tak stable because they are in this, I mean, the carbon is not obeying octet. Dia tak octet lagi ni dalam keadaan C plus ni. Okay, tapi dalam banyak-banyak yang tak stable ni, mesti ada yang lebih stable than the other. Okay, so tertiary is more stable, followed by secondary, and very unlikely will be primary and methyl cation. So primary cation dengan methyl cation is 2 different thing, okay? Primary cation, so the carbon is attached to 1 carbon. But methyl cation, nampak tak? The carbon is not attached to any of the carbon. Okay, the carbon is not attached to any carbon. So this is what we call methyl cation. It is not the same as primary carbocation. So this is very, very unstable. Okay, very unstable. So primary carbocation pun dah diconsider sebagai unstable lah. Okay, so it has more hydrogen. See, this one tak ada hydrogen at all. So the lesser the hydrogen present in the carbocation, okay, the stable the carbocation become. Okay. Okay, so note, we have a note here. The alkyl group is electron donating that increase the electron density on the positively charged carbon. Okay, dia membantu. Dia kan ni positively charged, so dia tolak the electron density to like macam buffer, okay, the instability of the carbon. Okay, sebelum nucleophile attack and add itself, and finally the carbon has 4 bonds. Okay, let's look at another example. Hydrohalogenation of 2-pentene. Just now we have propene, kan? Now we have 2-pentene. This is also unsymmetrical. Is it? Yes, unsymmetrical. Okay, so when double bond carbon atom have same degree of substitution. Same degree of substitution. Okay, a mixture of addition products will be formed. Kat sini, kalau the carbocation form tu is either tertiary or secondary, dia akan ada mixture. Dia ada that probability. Yang dia boleh duduk di sini dan dia boleh juga duduk di sini. Okay? Tapi that is only possible for tertiary and secondary carbocation. Okay? Okay, tak apa. Let's look at example. So we have 2-pentene here. So this is what it meant by same degree of substitution. Okay, as you can see, this carbon has 1 hydrogen and 1 alkyl group, right? Same goes to this carbon. This carbon is also having 1 hydrogen and 1 alkyl group. Okay, dia maksudnya dia punya degree of substitution dia tu sama. Okay, this is mono-substituted and this is also mono-substituted. So kalau case macam ni, dia ada 2 probability lah. So the BR can be placed on both side. Dekat sini and this carbon. Okay, so these are the two options. So Br can be placed here and Br can also be placed to this carbon. As long as yang double bond tu saja, yang lain tu you remain as is. Okay, inilah maksudnya a mixture of product will be formed. Dia ada dua probability of halogen punya placement. Okay. Kalau case ni dia samalah, mixture of addition product will be formed. Dia akan sama. Tapi ada keadaan yang rasanya saya tercakap bukan dekat yang remember tadi yang tertiary dengan secondary tadi kan. Yang saya tercakap tertiary dengan secondary. Yang itu bukan case yang ni. Yang ni ini case di mana dia dua-dua same degree of substitution. Yang saya cakap tertiary dengan secondary tu dekat sini. Terawal pula. Okay. Prediction major and minor product. Prediction of major and minor product. Okay. Alright. Okay. Dia bagi statement pula kat sini. Okay. When double bond carbon atom in alkene have substitution with one highly substituted over another, a mixture of major product and minor product are formed. Again, it's based on preference. For example, 2-methyl-2-butene. So the intermediate form will be secondary and tertiary carbocation. Okay, alright. So yang dua probability kan, kalau yang di place here, it can also be placed here. So you have to consider in terms of the carbocation, the stability of carbocation. Okay, so we know that tertiary carbocation is more stable. So the tertiary carbocation will be more likely to be formed and therefore it will become the major product later on. It will form the major product. And this one will form the minor product. Okay. So because the more stable tertiary carbocation is formed more rapidly than the less stable secondary carbocation, so major product is produced from the tertiary carbocation. Okay, cuba tengok contoh. Okay. 2-methyl-2-butene. Okay, so you pun identify. Okay, so we have the double bond here. So kita identify this. This is 1, 2. This is secondary carbon, right? This one has one hydrogen attached to it. So this carbon, yang the red one, is secondary carbon. Why is it secondary? Because this carbon is attached to this methyl group and this carbon. So it is secondary. How about the blue carbon here? So the blue carbon here is a tertiary carbon because this carbon is attached to another 3 carbon. This one, 1, 2, 3. Okay, yang directly attached to it. Jangan tengok yang jauh-jauh tu. Kita cerita yang directly attached to it. So it is a tertiary carbon. It contains 2 alkyl group and no hydrogen. Ini pun kita dah boleh identify. Maksudnya later, okay, so this one will form secondary carbocation. This one will form the tertiary carbocation. Okay, so this is the reagent used, HBr in ether. Ether ni dia punya solvent lah. Okay, alright. So ada dua possibility. Possibility 1, possibility 2 kan. Alright, so the H will be added first dekat this carbon, the blue one just now. Okay, so leaving this carbon as secondary carbocation. Step by step masukkan dulu hydrogen. And then ini akan jadi carbocation. You masukkan dekat kalau you nak secondary carbocation, that means you have to add in hydrogen to the tertiary carbon. Okay, and then later on, Br, okay, will be added. Will attack the carbocation and add itself to the carbon. Okay, so this is secondary carbocation. So secondary carbocation is less likely preferred, less likely preferable. Okay, because in terms of the stability, it is less stable. Okay, another option is tertiary. When it forms tertiary carbocation, so the hydrogen will be added to the one that has more hydrogen. Okay, yang red carbon tadi. So kan dia ada satu hydrogen dengan situ, yang this one tak ada hydrogen at all. So the hydrogen will be added to this carbon. Ini follow Markovnikov. Okay, hydrogen will be added to the carbon that has more hydrogen attached to it. So this will cause the carbon here to become tertiary carbocation. So we know that tertiary carbocation is very stable compared to secondary. It's stable compared to secondary. Then later on, Br minus will attack the carbocation and add itself to the carbon. So this will be the major product. Kenapa? Because it produces stable carbocation. That's the answer. If you are asked, okay, reason why tertiary carbocation, tertiary carbon is preferred, okay, it's because of the formation of tertiary carbocation is more stable. Okay, so dia itulah. Faham tak? Ada soalan tak? Nampak dia ada nak kena. Ya.
Boleh tak Bedul explain balik yang secondary carbocation tu, sebab kalau yang tertiary tu dia ikut Markovnikov kan? Yang secondary tu kenapa
Dia terbalik lah. Okay, dia opposite of Markovnikov.
Itu certain situation je kan dia akan jadi macam
dia usually when it involves secondary dengan tertiary. Okay, secondary dengan tertiary. Maksudnya you check, you ada double bond, you check the carbon for both yang attached double, yang has the double bond kan. Okay, this one is this carbon like this one. Okay, dia kan. You check. Okay, this carbon is secondary carbon kan, and this carbon is tertiary carbon. So when this is secondary carbon, so it has the tendency to form secondary carbocation later on. Maksudnya hydrogen will first be added to this carbon and leaving this as the carbocation. Tu yang jadi secondary carbocation tu. Okay? So ni dia tak follow Markovnikov, dia anti Markovnikov. Markovnikov cakap apa? Hydrogen akan masuk dekat dalam dekat carbon that has more hydrogen attached to it. Tapi yang secondary carbocation ni dia tak follow. Hydrogen masuk dekat carbon yang tak ada hydrogen dekat carbon tu. Okay? So ni tak follow Markovnikov. Bila tak follow Markovnikov, dia jadi minor. Yang follow Markovnikov akan jadi major product. Faham tak?
Random, sebenarnya kalau soalan biasa dia tanya dia soal identify je lah.
Soalan dia akan dia mungkin dia akan normally we would go for major product lah. Okay, so the main thing is the major product. Minor tu unless it is specified in the question, then you have to show for the minor product. Okay, but normally kalau dia tak cakap major ke minor, it is understood that you should be showing for the major product. So you kena tahulah major product macam mana nak form major product. Kalau the reaction form carbocation, dia kena prefer tertiary carbocation. Maksudnya tertiary carbocation tu, the Br will be attached to the tertiary carbon later.
Kiranya dia follow Markovnikov je lah kan?
Dia follow Markovnikov. Yang tak follow Markovnikov, dia akan jadi minor. Tapi this is only applicable for secondary dengan tertiary. Kalau primary dengan tertiary ataupun primary dengan secondary, the primary will not be formed at all. Sebab tak stable. Okay, Markovnikov tu pun dia based on the stability of the carbocation. That's why tertiary is more stable kan. That's why dia sebab it will form as major product. Okay, sebab Markovnikov tu dia cakap based on the stability of carbocation. Faham tak?
Faham, madam.
Okay. So kalau you ada, you check dulu. Okay, ni tertiary dengan secondary. Oh, confirm ada minor, bukan confirm, maksudnya dia akan ada major dengan minor. Kalau you check tu, tertiary dengan primary ataupun secondary dengan primary, that primary will not be formed. Tak payah susah-susah nak tunjukkan. Okay, ni kejap lagi BR duduk kat sini pula. Tak payah. Go for the secondary or tertiary. Because that will be the sole product form, the only product form in the reaction. Sebab apa? Primary is very unstable. Okay? So kalau dia tertiary dengan secondary, dia ada major and minor. Kalau dia sama, case yang sama, maksudnya ni, you check you tengok ni ini kan secondary. Ini pun secondary. Secondary. So this one, dia ada mixture. Dia mungkin 50% of this, 50% of this, ataupun 60-40 macam tu lah. Okay? Dia ada dua case kat situ. Dia tertiary dengan secondary. So, then secondary and secondary. Kalau tertiary dengan primary, ni tak boleh. Secondary, primary, tak boleh. Go for this one only. Okay, follow Markovnikov. Okay, faham tak? Okay ke, guys?
Okay, madam.
Okay, how about the rest?
Okay, betul.
Okay. Okay, madam.
Masuk good Okay, banyak lagi, jauh lagi perjalanan kita ni. Masih bertahan, bagus. Aduh, ya Allah, lagi 6 minit. Macam mana habis ni? Okay, checkpoint 14. Question 1. Nak buat yang mana? Draw the structural formula of the product form for a reaction between Hi in ether with the following alkenes and outline a mechanism. Okay, semua dia bagi mechanism. Sebab bila ada mechanism, you kena be careful. Most likely, dalam senang cerita, in exam, there should be at least one mechanism will be coming out. Cuma tak tahu yang mana. Sebab kita ada banyak. One or two lah mechanism will be coming out. Kalau dah keluar satu atau dua tu, yang lain semua dia tanya, name the product form, draw the product form, name the reagent. You tak percaya, pergi tengok past year's question, itu style dia. Okay, cuma kita tak tahu mekanisme apa yang akan keluar. Sama ada alkene ke, alkohol, alkyl halide pun ada mekanisme juga. Alkene just now pun, last time kita ada mekanisme juga kan. So, tak tahu yang mana satu. Okay, you nak yang mana sekarang ni? Okay, question 1 satu contoh, question 2 satu contoh. Butir. Which one? Nanti nak B kan? Nak mana? Nak A ke nak B? Okay, question 1.
B, madam. B.
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 Nampak cyclo nak B. Okay, alright. Okay, let's start lah. Saya boleh tunjuk je jawapan. Tapi kita kena start from the beginning. From scratch. Okay, baru kita tahu perasaan. Perasaan berdebar bila nak jawab soalan tu kan. Nak start dari mana. Okay, cyclohexene dengan HI. Is it? Cyclohexene, ENE, and HI. Draw the structural formula of the product form and outline the mechanism. Basically, you have to show the mechanism. Okay? Alright, so let's draw the cyclohexene first. Kalau dah cyclohexene pun salah draw, of course lah produknya akan jadi lain. Okay? Cyclohexene. That means we have 6 carbon. So let's have the double bond here. Okay, alright. Ni sebenarnya senang tau. Sebab apa? Sebab ni, this is secondary. This is also secondary. Dia punya option dia sama ada BR kat sini ataupun iodine kat sini. Or the other one is here. Sebenarnya yang ni sikit, satu butir ni. Tak apa, you try. Okay, try. Okay. Okay, so kita dah draw. This is how cyclohexene looks like. Okay. And then kita identify, so we have double bond there. So identify this carbon. This is secondary carbon, right? This carbon is attached to these two carbon. How about this one? It is also secondary carbon. Okay, just to highlight lah on that. Why? Okay, alright, react with Hi. What mechanism kan? Okay, first, the nucleophile attack, the double bond attack. Okay, attack the H. Okay, tak cantik. But ni cerita tau. Mechanism ni kronologi. Okay, we'll attack the H. Nak ambil H, nak remove the H. So what happen is that this bond will be broken down. So both of the electron will be given to iodine. And okay, so H will be added to any of these two. Sebenarnya dia macam simetri. You try belah. Dia simetri juga kan? Okay, so the H will be added to any of these two lah. So katakanlah saya nak letak H dekat sini. Okay, and leave this one as the carbocation. You have to show the carbocation as the intermediate. Okay, right, and then you have the iodine just now, the iodide. Okay, this iodide. Then this iodide will behave as nucleophile and attack the carbocation, which is now behave as electrophile, and attach itself there. So, you akan ada iodine lah dekat sini. Okay, so tadi ni H saya highlightkan because dia nak tunjukkan this is the added hydrogen. Okay, so sebenarnya you nampak je, you letak carbocation kat sini ke, ataupun dekat atas ni ke, ataupun dekat bawah ni, you are actually producing the same product because dia tak ada apa nama? Dia tidak ada what do we call that? Tidak ada substituents to this cyclohexene. Okay, so you mungkin akan ingat, okay, another option adalah kalau ni carbocation dekat sini, the other option would be macam ni kan? You akan buat macam ni. So H masuk dekat sini. This is this carbon will bear the positive charge. And then the iodine attack. Macam biasa, you akan buat attack this carbocation. So it will become like this. Macam lain kan position dia tu kan, tapi sebenarnya sama. Okay, ni hydrogen, the added hydrogen. You mesh, tak payah tunjuk pun tak apa sebab hydrogen in skeletal is not supposed to be shown lah. Okay, tapi saya tunjuk for the sake of the addition of hydrogen just now. Kenapa saya kata it's actually benda yang sama, nampak location berbeza kan? Sebab you try namakan. Bila you namakan, you dapat. Bila you namakan, you kena go through the process kan, the 5 steps kan. It will produce the same name. It's actually the same compound sebenarnya. Sebab you akan start numbering from here. 1, 2, mana-mana lah you nak ke atas ke bawah ke, you akan dapat 1 iodo cyclohexene, right? Same goes to this one. You can start numbering from here. 1, 2, ke bawah ke atas, doesn't matter. Okay, so you still will get iodine as at carbon number 1. So 1 iodo. Ataupun without the 1, iodo cyclohexane. Okay. Alright. Itulah dia punya ni. Dia punya 4B. Okay. Right. So A just now 1 butene. 1 butene is interesting. Tapi dia bukan interesting as in cuba you draw. Saya nak buat skeletal boleh tak? You boleh nampak kan skeletal kan? 1, 2, 3, 1, 2, 3, 4. 1 butene. So the double bond should be placed here between carbon number 1 and carbon number 2. 1 butene. Okay, and then you identify. Kan saya ajar tadi, okay, identify dulu. Probability nanti dia akan duduk dekat mana. Okay, so this would be secondary, right? This carbon will be secondary. How about this one? This is primary. So this primary, kalau dia dibuat reaction, nanti dia akan form primary carbocation. So primary carbocation is very unstable. So it will not form. So, bila dia form product sebenarnya, dia hanya akan form sole product which should be here. Iodine should be placed here, only here, not here. Okay, because this here will form carbocation, primary carbocation. Okay, right. Okay, number two, question number two, nak yang mana? A ke B?
B.
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 Okay. Write the mechanism and predict the major and minor product in the reaction mechanism kena ada. Predict the major and minor product in the reaction between hydrogen bromide and these two. So you choose B just now kan? You choose B. Okay, so let's do B. Apa tadi? 3-methyl to pentene. 3-methyl to pentene. Okay, so saya nak go for skeletal lah sebab skeletal lebih cepat sebenarnya, lebih senang. Bukan lebih senang, dia lebih cepat. Okay, pentene. Okay, so there should be 5 carbon. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. At carbon number 2, we have double bond. So this is carbon number 1, number 2. Okay, so it should be 2 and 3. Carbon number 2 and carbon number 3. Okay, so that's why dia 2 pentene. Okay, and then at carbon number 3, we have methyl group. Carbon number 3, we have methyl group. So this is carbon number 3. Okay, right. Okay, so kita pun check lah saja nak bagi prediction awal. Okay, sebab we know that it will react with HBr. Okay, Br will be added. So Br, there are 2 probability. Because why? Okay, kita identify this carbon here is secondary. And this carbon here is tertiary. Okay, so during the formation of the product, there will be the formation of secondary and tertiary carbocation. But the one that is based on Markovnikov will be the tertiary lah. Okay, tertiary maksudnya dia akan form as measure product. Okay, right. So saya clearkan everything supaya tidak serabut. React with HBr. Macam biasa, dia akan attack the H. Okay, so this one will be broken. Both of the electron will be given to Br. Okay. Right, dia punya arrow kena melengkung Dia bukan straight arrow. Dia memang in organic chemistry dia curve arrow. Curve arrow. Dia bukan straight macam tu ataupun curvy bunuh. Okay? So it should be curve arrow. Okay, so ada 2 probability here. Okay, so let's go for kalau based on major product lah, okay? Okay, this one. Okay, so H will be placed first. So H will be placed to the carbon that has more hydrogen, which is the secondary lah, here. Okay, so this is the added H because here sebenarnya kita ada H yang unseen H. Sebab dia skeletal kita tak tunjuk. So we have 1 H attached to the carbon. Okay, alright. So here will then be positively charged. So we have the tertiary carbocation. Okay, and then the Br. Br just now. So we have Br here kan. Br minus. Br minus as a nucleophile. So this nucleophile will then later attack the carbocation. Okay, it will attack the carbocation and attach itself to the tertiary carbon and become this final product. Okay, buruk ya, minta maaf. Br. Okay, so this will be your final product. So this will be major product. How about the minor product? Okay, sebab ni dekat tertiary. Okay, how about minor product, guys? So, you akan produce opposite of this one. Okay, opposite of tertiary ni. Maksudnya H akan duduk dekat tertiary. Okay. So, H masuk di sini. So ini akan jadi ini secondary kan? So, here will be the secondary carbocation. Okay, and then we'll react with Br minus. Br minus is the product. Is the apa nama tu? The nucleophile that produced from this cleavage. Okay, so it will attack this carbocation and attach itself to this one. See? So this is what we call minor product. Okay, sebab dia punya competition is between tertiary dengan secondary. So in that case, we have major and minor. Okay. Inilah, so this is for B. Nampak tak? Dia ada satu je sebenarnya. Ini benda yang sama like I've shown to you just now. Okay. So this is for B. And this is for B also just now. So this is for tertiary and this is for secondary. Ni dia buat for this is mixed version, condensed dengan expanded. Just now saya tunjukkan awak skeletal kan. So this is condensed plus expanded. Okay. Right. Ini pun boleh buat sendirilah. Identify an alkene that should be used as a starting material to produce 3-bromohexene. So given is the product, so you have to identify the starting material. Okay, the starting reactant that it could be used to produce these 3-bromohexene. So macam like you have to work reversely. Okay. Okay, so unfortunately cita-cita saya tu tidaklah kesampaian. Okay, so kita kena stop dekat reaction number 4. We have one more reaction and then the other subtopic is also about alkene, but that is the unsaturation test for alkene to identify alkene. Okay, let's say you have 2 unknown bottles in the lab. Okay, what you know, you don't have the information about these 2 bottles. The only thing that you know about these 2 bottles, one is alkene, the other one is alkene. Tapi tak tahu yang mana. Okay, so you can conduct a test in order to identify which one is alkene, which one is alkene. So itu test yang kita akan cover lah later. Tapi untuk reaction, the last one will be the hydration. Okay, tapi let me just give you a brief idea on this hydration. Basically, it is the same as the concept is still the same as what we have learned for hydrohalogenation just now, because dia punya product added will be H dengan OH. Just now yang hydrohalogenation just now H dengan Br, right? So this one kita ada H and OH. So follow Markovnikov. Okay, follow Markovnikov. So dia akan prefer more stable carbocation. Okay, so more stable carbocation will form as the major product. So luckily you dah learn just now. So you have the idea already. So during the reaction mechanism tu, patutnya you lebih cepat lah untuk nak grab. Okay, alright. So it will produce alcohol as the product. Okay, we produce alcohol as the product. Okay, so tu idea yang saya bagi. So later kita akan cover during after raya break lah. After raya break you guys raya jangan raya beringat sikit lah nak exam So raya dan naik raya terus gone, hilang, lupa terus. Okay, right. Any question related to the previous slides just now? Ada ke?
No, madam. Clear, madam.
No, madam.
Okay. Right. Kalau tak ada, balik cepat-cepat buat mind map. Entah buat ke tidak tu tak tahulah saya. Okay. Cepat-cepat cover sementara kita ada 4 reaction for this alkene. Okay. Next kita akan tambah lagi hydration. Okay, so you kena on track, jangan tertinggal. Kita ni memang lecture kita ni dah tertinggal, tapi you tu jangan tertinggal. Dengan saya tu, you make sure saya depan sikit, you belakang. Make sure, jangan, okay, jangan begitu. Right, okay, so that's about it for today, guys. So thank you everyone. So we'll see you during tutorial. Okay, see you. Bye-bye. Assalamualaikum.
Thank you, man.